Hi, everyone. Can you hear me?
Yes.
Awesome. Good afternoon. My name is Giovanni Cassani. I will be presenting work that I did with Niklas Limacher, building on his bachelor thesis. And we did research on systematicity in form meaning mappings, and especially whether it has anything to say about language acquisition. Wait, I can't access my slides. Oh yeah, now I can. The computational approach that we investigated falls under the broad name of form-semantic consistency. And at a very abstract level, you can think of this as bridging two feature spaces. On the one hand, you have form, here visualized as a simple two-dimensional geometrical space, and you have semantics, same kind of 2D dimensional spaces. These are just blunt simplifications. The important thing is you can have this in any way you want. I'll go into details later about how we implemented this. The important part is that you will have a target word in this space with some neighbors. And you will have the same target word in this other feature space, again, with some neighbors. Now, the more the neighbors resemble each other, the more the neighborhood structure resembles the neighborhood structure in the semantic space resembles the neighborhood structure in the form space for a target word, the higher the consistency will be. If we were to find that these 5 nearest neighboring form were scattered all around in semantic space, then we would have very little consistency. This is the general idea that we move from. Why should this be any interesting to research age of acquisition? There is quite a bit of work done in comparing representational spaces in a representational similarity kind of way. So you derive some representations of word forms and you check to what extent they are similar to each other. You do the same for semantic representations and you check to what extent they're similar to each other, and then you check to what extent they correlate. This research has uncovered that there is a small but not reliably non-zero correlation between similarities in form and similarities in meaning. But it also highlighted that this similarity is higher for early acquired words. So if this is the similarity of cat to all the other words in the language in form space, and this is the similarity of cat to all the other words in the language in semantic space, you see that here, this is just a toy example, but this part of the space basically resembles this part of the space, whereas here it's pretty much random. Systematicity is a pretty broad context, but in general, it refers to the ability of, to the coherence between form and meaning. The main example of systematicity is, of course, morphology. When you add an S to a noun, you typically get a plural in English. But there are also examples of systematicity that are that exist below what we can say is the morpheme level. Phonostemes are one example where you have statistical relations for certain letter sequences. A very known one is GL as the beginning of a word, which tends to be to appear in words related to light, but not only. There are counterexamples. And also phonosymbolism, where people tend to match certain strings to certain shapes, even though the strings per se don't have any meaning in the language. Next to systematicity, we also have iconicity, which is not really language internal, but is an interface between language and the word. So iconic words tend to replicate some perceptual property of their referent. We may have a wolf howling, and our English word to refer to it sounds a lot like the sound of a howl. All's good up until here, nothing new. However, what if we don't yet have a meaning representation for a word, and we would like to estimate its degree of form meaning systematicity? Moreover, since we have this neighborhood structure in both form and meaning, it could very well be the case that the effect of systematicity boils down to words being very much entrenched in both spaces, in both representational spaces. So it's not really about systematicity, but it's about the fact that certain words have very close neighbors in both spaces. And there is a documented acquisition advantage for words that have a denser form and semantic neighbors. Also, there's always the possibility that systematicity isn't really capturing what we think it is. We find a way to compute it, and then it turns out that you're just, catching noise. So the working hypothesis we started from is that learning precise semantic representations from exposure to language and context takes time. You need several exposures in context to really hone your semantic representation of certain context. Maybe languages hint to this kind of more precise representation by the word form itself that is used to refer to that meaning representation. So words for which it is easier to guesstimate the meaning from the form end up being learned earlier because you sort of get a head start. You will end up to this representation, but the form already gets you here. If the form is misleading and would get you here, then you would have a longer, it would take longer to come to the right representation. Why is form-semantic consistency an interesting measure to approach this problem? Well, it's been tested and proven in a bunch of studies, modeling reaction times in lexical decision, both considering orthographic to semantic consistency, so encoding word form through orthography, and as phonology to semantics consistency, so encoding words as phonological forms. Also using a bunch of different statistical models, from linear regression to mediation analysis to piecewise generalized additive mixed models. And the results are pretty robust. Form-semantic consistency does predict reaction times. It also predicts priming effects. In particular, orthography to semantic consistency turned out to explain independent variance in the magnitude of the priming effect. So it seems that the word semantics is already accessed at very early stages of processing. And crucially, semantic access is constrained by the orthography. Also, FSC estimates have been shown to predict reading times and to interact with surprisal. So when the sentence context is only moderately surprising, the orthography becomes an interesting source of additional information to activate word meaning. Also, unlike the studies, the representational similarity-like studies, where you need to have representations in both spaces in order to compute a correlation, FSC is really a generative model because you can look at the neighborhood structure in form and sort of estimate what the semantics of this word form should look like based on its neighborhood in form space. So we have actually a way to project a word form that we have heard, for example, for the first time into meaning space without considering sentential or situational context. So in short, this study asks the primary question whether we can predict age of acquisition patterns using form semantic consistency like we can do with lexical decision times. Then we also check whether the effect of systematicity is robust when we control for neighborhood effects in both form and meaning. Whether FSC is robust to changes in the size and composition of the reference vocabulary. It's a neighborhood-based measure. If you change the kind of words you consider as possible neighbors, you could get surprises. And thus, in the end, whether FSC is really capturing something close to systematicity or maybe some epiphenomenon of these representational spaces. How did we do this? There are two ways in which you can actually implement FSC. You can consider neighbors as the words that include your target. So if your target is red, credit will be a neighbor, or you could use Levenstein distance, in which case red and rod are far closer in terms of edits you need to do upon the string in order to get to the target. These two methods have been tested in the literature with alternative fortunes, so it's interesting to see which one works better for acquisition. We can get back to this during the question time if you want to. And also two ways of scaling semantic similarities. Also, both of them were already tested in the literature. We can either give more prominence to more frequent neighbors in form space. So the semantic representation of this more frequent neighbor will weigh more when it comes to compute the coherence of these neighbors with respect to the target. Or we could weigh according to the inverse of the distance. And so this neighbor, which is closer to the target in form space, will weigh more when we compute the coherence with respect to the target in form space. Specifically, this weighting scheme was combined with this strategy because it's a model that has been tested in the literature in this configuration. And this one has been combined with the Levenshtein distance approach. Of course, to carry out this study, we used several data sets, age of acquisition norms, of course, both test-based and subjective, Subtlex US to extract frequency estimates, and our reference vocabulary to sift through possible neighbors, concreteness norms as a control variable, valence norm as a control variable, the MALT dataset to extract coulthurst and as a measure of phonological neighborhood density, Iconicity norms because we're dealing with systematicity and we don't want to run the risk of actually saying it's systematicity when in the end it's iconicity. And then Morpholex to discriminate between mono and polymorphemic words because there is an acquisition advantage for monomorphemic words and we don't want any pattern that we might find to actually be confounded by this. All these predictors have been shown to reliably influence age of acquisition in a number of studies, so we want to control for that. One thing that I didn't mention is in the end, we decided to encode word forms as phonological strings. And so compute Levenshtein distance over phonological representations. Those come from Selix. The meaning representation is a word embedding space taken from a study by Mandera and colleagues, which validated embeddings on a number of psycholinguistic tasks. So our meaning representation is a co-occurrence-based prediction model word-to-vec, and our form representation is phonological transcription. So the main analysis consists in trying to predict objective age of acquisition norms using a linear regression and a random forest to counter the possible harmful effect of collinearity. We have a bunch of control variables, as I said, frequency, concreteness, norms, valence, the length in phonemes, the phonological neighborhood density, the semantic neighborhood density, also computed from the embedding space, and the morphological complexity. The continuous variables were box-Cox transformed to make them more normal-ish, and then Z-standardized. So every coefficient you'll see is a beta coefficient. They can be directly compared. Then we fit a baseline statistical model only including control variables, to which we add target variables or interactions, and then we measure the change in the AIC to determine whether our target variable improves the model fit. And it turns that the phonology to semantic consistency estimated using target embedding neighbors, but also Levenshtein distance neighbors, they all have a significant effect on age of acquisition. The Levenshtein distance turns out to be better at predicting this. The effect is robust in terms of delta AIC with respect to the baseline statistical model, and the effect is negative. So it is indeed the case that, or at least it seems to be the case that words with a higher coherence between their neighborhood structure in space, in form space, and their neighborhood structure in semantic space, these words are acquired earlier, or tend to be acquired earlier. The same comes out from a random forest analysis. We see that the phonology to semantic consistency is a fairly relevant predictor on par with phonological neighborhood density and semantic neighborhood density. For the Levenstein distance, it's actually one of the most useful predictors of age of acquisition, only second to frequency, which was pretty neat to observe. We did a separate control for iconicity because we have far fewer norms. So you see that the sample size shrank quite a bit. The coefficient is, again, so there should be a minus here, as you see from the t-score. So again, we see that phonology to semantic consistency improves the model fit also when we control for iconicity. So the two are not capturing the same thing. And again, we see that phonology to semantic consistency is a reasonably good predictor of age of acquisition also in a random forest. And again, the Levenstein distance one turns out to be better than the target embedding. One robustness check, we basically scrambled the form meaning correspondences and recomputed everything 1,000 times to derive a distribution of AIC scores under sort of a random vocabulary mapping where we don't expect to observe any particular systematicity. And we see that the random distribution is very close to zero, whereas our observed statistic is very much outside of this interval, suggesting that we are indeed capturing something about the systematicity in form meaning mappings in English. We also controlled for the neighborhood structure by sampling out of the reference vocabulary, either 50 or 75%, 500 times each. And again, we see that there isn't a big difference with respect to our observed statistic. If anything, it seems that when you use a smaller reference vocabulary, you get even stronger effects. But this is not the purpose of the study, so I won't draw conclusions from this. What does this all mean in my last few minutes? How could an algorithm like FSC work in acquisition? Well, you hear a new word for the first time, let's say Mordor. Now, pretend you haven't read The Lord of the Rings. You hear Mordor in a pretty unconstraining sentence, like tomorrow we go to the Mordor. And you don't know what it means. The context doesn't say much, just that it's probably a noun and maybe a place. But if you use FSC, you might get scared. Because the neighborhood structure in form triggers words like murder or sorter, which have a pretty coherent semantics between themselves. And you might say, well, okay, based on the relations in form space, this word may mean something close to these other words. And so you might not get very excited about going to the Mordor. Now, our work showed that words for which this process works better, so that the semantic neighborhood structure is coherent, tend to be learned earlier. So there seems to be an acquisition advantage for this kind of process, but we haven't tested this process. So here I'm speculating. The interesting thing is FSC is a process by which you could infer meaning by analogizing over similarities in form space. But this only works if learners can approximate lexical semantics at least most of the times. So if the process works for many words, otherwise you would dismiss this as completely irrelevant. And for it to work, there needs to be some degree of systematicity in form meaning relations. FSC so may be an account of how learners exploit systematicity in a productive way to bootstrap learning of novel words. And it turns out that FSC doesn't simply capture activation patterns in the mental lexicon, which is the explanation for why it predicts lexical decision latencies, but it also captures learning patterns. So systematicity seems to play a facilitating role during both learning and processing. Now, this analogical process may very well be similar to the one that is thought to be at the bottom of iconicity. Iconicity is an analogy between perceptual semantics and word forms, but if you replace the perceptual semantics with lexical semantics, then you get pretty much FSC. So it may be that this analogical process works the same way, but it just relies on different representations, because in the beginning, you mostly have perceptual meaning representations that then you enrich with lexical ones. So once learners know enough, they can move to a lexical semantic representation. Now, learners need to know some words for FSC to work. So we're not speaking about the earliest stages of language learning. We did control for morphological complexity, but we did not quantify how much of the effect of FSC is due to morphological productivity, etymology, or sound symbolism, just that there is systematicity and that it can be exploited. Also, we didn't test it other languages. Maybe there is a role for morphological complexity here. Very briefly, there may be a role of phonotactics. We don't really know how kids compute form similarities. There may be a role of vocabulary knowledge. We did test samples out of the reference vocabulary. I'll stop. Just thanks to Niklas, and I'll get everything else in the questions.